Hello students, welcome to Mathlearn and I am with you Arup sir. Children, we were continuing congruency in triangles. We have already done part 1. In that we have given some brief introduction what congruency mean, and we have seen different criteria of how congruency happens between two triangles. And we have, just to brush up again, we have done SSS criteria, SAS criteria, AAS criteria, and RHS criteria, and ASA criteria. These 5 criteria are there. Apart from there, you can say it is not a valid criteria. So these criteria, once you have learned, now we can do from question number 2 to 7 of exercise 9A of Concise Mathematics, Selena publication, and we'll explore more the criteria, how to utilize the criteria. Let's begin question number 2. Question number 2, here is the figure given. The given figure shows a circle with center O. It is a circle with center O. P is the midpoint of chord AB. AB is the chord and P is the midpoint. Show that OP is perpendicular to AB. Okay, let's write what are the given things. Given P is the midpoint of AB. See, P is the midpoint of AB. What does it mean? It means that P is bisecting line segment AB. That means AP equal to BP. See, if some line segment, if some point is given and it said that this point is the midpoint of the line segment, that means the two sections of the line segments are equal to each other. That means AP equal to BP, it is given. And anything else is given? No, nothing is given except O is the center of the circle. Now you have to prove, OP is perpendicular to AB. Now how you say this OP is perpendicular to AB? If this angle is 90 degree, then you can say that OP is perpendicular to AB. That means if it is making this OP is exactly vertical, that means OPB is 90 degree, then you can prove that OP is perpendicular to AB. Here you have to do some construction. Yes, construction. That means apart from given the figure, you have to do something in the figure. You have to make some extra thing. What extra thing? You have to join A to O. You have to join O to A and O to B. You can say construction joined OA and OB. Here also I can do the same thing. OA and OB. It is given AP equal to BP. Now you have to give the proof. Few things you have to remember for the solution of this congruency sums. One, something is given to you that you should write it very clearly. what are the things given, what you are going to prove, and if there is any construction you are doing, that also you should mention it, and then you are giving the proof. See, in this triangle, here two triangles are formed, OAP and BOP. In triangle AOP and triangle BOP. What are the things you see they are equal? Congruency rule, you have to make few parts equal to few parts of the other triangle, and you have to check whether they are coming in the congruency criteria or not. That is the way you do congruency. Come on. OA is equal to OB. Is it not? OA equal to OB. Now you have to give the reason for everything what you mention here. OA equal to OB, how did you find? Because OA is also radii and OB also radius. Both are radius. So you can say radii of the same circle. See, radius will be always same. So how many radius you draw here from O to the circle, all radius are equal. So OA will be equal to OB. So you can mark here OA equal to OB because they are radii of the same circle, and AP equal to BP. AP equal to BP. Look here, AP equal to BP. It is given in your question. So you can write this as given. And see, this is OP. OP equal to OP. Why OP equal to OP? Because let us draw the figure. O, A, P, OP equal to OP. See, this is also OP. OP is there in this triangle, as well as OP is the line in the side of the OPB. So you can say OP is common side. So OP equal to OP. Now let us OPA, OPA and OPB. Let us see the congruency here. OA equal to OB, OA equal to OB, AP equal to BP, AP equal to BP, and OP is equal to OP. So these two triangles, triangle AOP, congruent triangle BOP, triangle BOP. You have to take care the sequence of the vertices. Sequence of the vertices, what I mean that after A, you are going up and then again you are coming down. So AOP and here BOP. So you cannot write AOBP and BPO. Then your sum will be wrong. So triangle AOP and BOP are congruent by SSS criteria. Now you know three sides, here three sides. They are corresponding and they are equal. So triangle AOP and BOP are congruent. But what am I getting out of that? Yes, this angle, see what happens in congruent triangle. If two triangles are congruent, suppose ABC and DEF. If these two triangles are congruent, then every corresponding side will be equal. That means AB will be equal to DE. AB is corresponding to DE, so AB will be equal to DE. BC will be equal to EF and AC will be equal to DF. There are 6 parts we'll be talking about in congruency. What are the 3 parts? 3 sides and 3 angles. So let us do the angles also. This angle corresponds to this. So angle A will be equal to angle D. Angle B will be equal to angle E. And angle C will be equal to angle F. So why we say, that is, we can write CPCTC. What is the meaning of CPCTC? Corresponding parts of congruent triangles are also congruent. See, this angle and this angle, corresponding angles, and if these two triangles are congruent, that means angle A equal to angle D, we can say by CPCTC, because there is rule that corresponding part of congruent triangles are also congruent. Congruent means, in every aspect they are equal. So this AB equal to D means AB and D are congruent. So now here you can say angle APO, angle APO equal to angle BPO. See, angle APO, this is P is corresponding to P of this triangle, so angle APO equal to angle BPO. But angle APO and angle BPO, what? It is making a straight line APB. So you can say angle APO plus angle BPO equal to 180 degree. Angle APO and angle BPO, see this angle and this angle, both angle, when you are joining, what is happening? It is making a straight line. So angle APO plus angle BPO equal to 180 degree. That means, but you have proved already APO equal to BPO. So you can write 2 angle APO equal to 180 degree or angle APO equal to 90 degree. When APO is 90 degree, that means OP is perpendicular to AB. That means OP is perpendicular to AB. Question number 3. Interestingly, this is just reverse of the question number 2. See, in question number 2, it was given that OP is bisecting AB. P is the midpoint of AB. Here, it is the reverse. It says that OP is perpendicular to AB, and you have to prove the same thing what was given in question number 2. It is given OP is perpendicular to AB, and we know now if OP perpendicular to AB, that means angle APO and angle BPO are 90 degree. Angle APO, this angle, and this angle OPB, they are 90 degree. OP is perpendicular to AB. It is given. And you have to prove that AP equal to BP. That means P is the midpoint of AB, or whatever you can say, AP equal to BP. To prove AP equal to BP. Here again, construction we have already did, that OA equal to OB, OA and OB we connected. Construction also you can write joined OA and OB. Now you have to give the proof. In triangle AOP and triangle BOP. See, these two triangles, let us make it true triangle AOP, A, O and P I will make such that P is the right angle. And OPB, see, in OPB also P is OPB, OPB is 90 degree. So angle OPB, that means P vertex is 90 degree. And OP, see, OP is common. OP is in this triangle also, OP is in other triangle also. So OP will be equal to OP, it is obvious. And OA and OB are equal. In the last sum we have discussed that they are radii of the same circle. So OA will be equal to OB. So we can write here OA equal to OB, radii of circle, and angle OPA equal to angle OPB 90 degree. It is given. APO or OPA, OPB are 90 degree because OP is perpendicular on AB. And OP equal to OP. You can say this is common side. Common. So we can see triangle AOP congruent triangle AOP. So you have to move your hands like this. BOP. Triangle BOP. Now we have to see the congruency criteria. AO and BO are hypotenuse. This is right angle, and OP and OP are the side of the two triangles. So right angle, hypotenuse and side. So this is coming under RHS criteria or RHS rule. Now, what I have to prove? We have to prove that AP equal to BP. See, AP is corresponding to BP, and we have already proved that these two triangles are congruent. So, corresponding parts of two congruent triangles will be congruent. So, we can say AP equal to BP and we have to write CP, CTC. Congruent part of congruent triangles are also congruent. So AP equal to BP, what you have to prove? You have already proved. Okay, let's see number 4. In a triangle ABC, okay, there is a triangle ABC, A, B, C. D is the midpoint of BC. In just midpoint of BC is D. D is the midpoint of BC. Whenever you see D is midpoint of BC, that means BD is given equal to CD. AD is produced up to E. AD is produced up to E so that D equal to AD. Okay. AD is produced. You could understand that you have to join AD and you have to produce AD. That means you have to take it straight. How much? Up to E, such that D equal to AD. D will be how much? D will be equal to AD. That means AD is such that AD is equal to D. AD, if AD is 5 cm, D also 5 cm. Equal measurement you are producing. Okay, this much is fine. Now you have to prove. Okay, first one you have to prove. To prove triangle ABD congruent to triangle ECD. Now ABD, I can see ABD triangle is there, but ECD triangle is not there. So definitely you have to join the EC. You can write also in construction that joining E and C. So we have to prove that these two triangles are congruent. Let's do ABD and ECD. See, something is very clear. In ABD, AD is there. So AD is equal to, this symbol is very essential. See, one stroke. That means in the figure you can identify, okay, AD equal to DE. AD equal to DE. Because in ABD, AD is one side of the triangle, and in ECD, D is another side of the triangle. So they become corresponding sides, corresponding parts. And again, here BD, in this triangle, BD is there, BD, and I can see here BD equal to CD. And CD is part of triangle CDE, that means ECD. Fine. Two sides we got equal, but there is one more equal parts is required. So if, I don't know you are aware of or not, if two straight lines intersect each other, these two angles are called vertical opposite angle. Vertical opposite angle. That means this equal to this, and this will be equal to this one. They are vertical opposite angle. I level it 1, 2, 3, 4. So 1 will be equal to 3 and 2 will be equal to 4, because they are pair of vertical opposite angle. So is AE. See, AE is one line and BC is another line. BC is one line and AE is another line. AE. So and this is the D point. So this and these two are vertical opposite line. So ADB angle ADB equal to angle CDE, and you can write vertical opposite angle. Now we have to see the criteria. Let's draw two triangles ABD and triangle ECD. AD equal to DE, BD equal to BD equal to CD, angle ADB equal to angle CDE. So you can see clearly the corresponding parts is very clear. Angle D, AD side, ED side, BD side, CD side. So we can write triangle ABD, whatever is given. So triangle ABD congruent triangle ABD ECD. You have to write the criteria. You can see side, angle, side. This angle is between the two corresponding sides. So you can see, you can write S, side, angle, side criteria. So this way you could prove that first one, triangle ABD congruent to triangle ECD. Second one, you have to prove that AB equal to EC. Here only you can see triangle ABD congruent triangle ECD. You can write, we have proved in 1. In 1 number sum, we have proved this. So, AB and EC are corresponding parts. So, AB equal to EC, they are corresponding parts. So, I can write CP, CTC. So, this is proved. Once you have proved the congruency, then any congruent parts you can tell that they are congruent or they are equal. Number 3. In number 3, you have to prove AB is parallel to CE or EC. AB parallel to EC. See, AB, this is AB and this is CE. You have to prove AB and CE are parallel. Here if you can see B and C, this is the line, and ABC and ECB, this angle and this angle are alternate interior angle. They are alternate interior angles. This concept is in lines and angles. I will make the video and we'll talk in details about these rules. For time being, you just understand if two parallel lines are there, then interior angle, this angle and this angle will be equal. This 1, 2, 3, 4 interior angles, and if you see the alternate interior angles, this 1 and 2, they are equal. In case the lines are parallel, then alternate interior angles are equal, or vice versa. Vice versa means if alternate interior angles are equal, then the lines are also parallel. Here I can see angle ABD. See, angle ABD. Again you can see, you can write ABD and ECD are congruent. So angle ABD equal to angle ECD. Why? Same CPCTC. Because there this is corresponding parts, and corresponding parts will be equal of the congruent triangles, and they are congruent. So angle ABD, D somewhere this side, this place. Angle ABD and angle ECD are equal, but they are alternate interior angles. You can write these are alternate interior angles, hence AB and CE, or EC are parallel. So AB and EC are parallel. Okay, so this way we proved all the 3 points. Question number 6. The perpendicular bisector of the sides of a triangle ABC meet at I. Let's draw a triangle ABC. Question number 5 I deliberately left for you so that you also can try in between. The ABC is a triangle and the perpendicular bisectors of the sides. That means if you perpendicularly bisect the AC, that means you perpendicular bisect AC and perpendicular bisect, probably my drawing is not good. This will be like this, and this and this all will meet at I. Perpendicular bisectors of sides of a triangle ABC meet at I. This is I. Prove IA equal to IB equal to IC. Let's join IA. If I don't join, I cannot prove it. IB and IC. And they are the perpendicular bisector. Let's make it point P, Q and R. See, from I to P it is 90 degree, I to R this is 90 degree, and I to Q this is 90 degree. So these are the perpendicular bisector. That means P is the midpoint of AB. That means given, what are the given? AP equal to PB, because it is IP is perpendicular bisector. Perpendicular bisector means two things. One is this is the bisector, that means AP equal to PB, and angle API equal to 90 degree, because IP is perpendicular on AB. Similarly, IQ is perpendicular on BC, and at the same time BQ equal to CQ, because Q is the midpoint. Angle B Q I API, not only API, also BPI equal to angle BPI equal to 90 degree. Here BQI equal to angle CQI. CQI equal to 90 degree. Same way, AC is also getting bisected by this point R. This line IR. So AR equal to CR and angle ARI equal to angle CRI. This also 90 degree. These are given, so we have just noted down that maybe this will be beneficial to prove IA equal to IB equal to IC. Now IA equal to IB. See, IA equal to IC. IA and IC, now by this time you understood we have to take two triangles to prove the congruency. Then only we can say, see, IA and IC. IA and IC, if I take these two triangles AIR and CIR, we may get some clue. Let's give proof of that. In triangle AIR and triangle CIR. See, this is the I, this is I, A, C, this is AC, and this is the perpendicular bisector, this is the R. This equal to this, and this is perpendicular. So AR equal to CR, AR equal to CR, given angle ARI equal to angle CRI 90 degree because it is perpendicular, and IR, this IR is common in both the triangles. So IR equal to IR, you can say common. Now you understood AIR and CIR will be congruent. Triangle AIR congruent triangle CIR. By which criteria? Two sides, this side and this side, and angle is in between. So side, angle, side, angle, side. So AI equal to AIR and CIR are congruent. So we can write AI, see, AIR. Let's draw AIR and CIR. So can I say IA and IC, they are corresponding? Obviously they are corresponding because already we have proved that they are congruent. So IA will be equal to IC, and that is due to CP CTC. So IA equal to IC we have proved. If we can prove another one thing, IA equal to IB or IB equal to IC, we can establish IA equal to IB equal to IC. So IA equal to IB, you see IA and IB are these two triangles. AIP in triangle AIP and triangle BIP. This is the way you can say AP equal to BP. It is given AP equal to BP, angle API equal to angle BPI, both are 90 degree, and PI or IP equal to IP, both are common. Hence, triangle AIP congruent triangle BIP by same ICSE criteria. You can see this is the side, this is equal, these are equal. So side angle side, side angle side, side angle side. So this is ICSE criteria. Now you can see, you can write AI equal to BI by CPCTC. See, here we proved IA equal to IC or AI equal to CI. Here we proved IA equal to BI. So this bit by 1 and 2, combining Y1 and 2, we can write IA equal to IB equal to IA equal to IC. Already we have proved. So IC. This is our proof. So it is proved. Question number 7. A line segment AB is bisected at point P. Let's draw AB. And AB is bisected at point P. That means P is midpoint. And through P, another line segment PQ is perpendicular to AB. This PQ is perpendicularly drawn on AB. That means it is given this angle APQ and angle BPQ are 90 degree. Show that QA equal to QB. So what are given? Given AB is bisected at P, that means AP equal to BP. We can mark also AP equal to PB, and PQ is perpendicular. PQ is perpendicular, already I have marked. That means angle APQ and angle BPQ are 90 degree. This is also given. And now you have to show QA equal to QB. Definitely I have to make a construction. I have to join QA and QB. Okay, join QA and QB. Now it seems very easy. We can give the proof in triangle APQ, in triangle APQ and triangle BPQ. See, AP equal to BP Clearly it is given in the question. Angle APA, angle APQ equal to angle BPQ as their 90 degree. PQ or QP equal to QP, they are common. So triangle APQ will be congruent, APQ will be congruent to BPQ, triangle BPQ. Still, if some student have confusion how APQ and BPQ are congruent, again I will say draw two triangles, and you can draw two right angle also. P in APQ, P make right angle, and BPQ also, BPQ, see this angle is right angle, so this is P. Now AP equal to BP, so AP equal to BP, here you mark BP and symbolize that AP equal to BP. And QP and QP both are common. So you can write this side angle side. So they are side angle side criteria, they are congruent. APQ and BPQ are congruent. Now I have to prove that, see what you have to prove, that you can keep in mind. You have to prove, we have not written that, to prove what? To prove QA equal to QB. QA equal to QB. Now see, QA and QB, they are corresponding parts. So QA equal to QB, we can write very well because they are corresponding parts. So CP, CTC. QA and QB are corresponding parts, and already we have proven that APQ and BPQ are congruent. So corresponding parts of the congruent triangles are always congruent. That means equal. Okay. Today up to 7 only. In the next part 3, I will try to finish from sum number 8 to rest all. Hope you are enjoying congruency of triangle. If yes, give a comments